let's talk about Statistical Process Control, or SPC. Statistical Process Control is the use of statistics or mathematical models and graphs to determine when we're getting to a place where we're producing something that may not be up to our quality standard. In this video, I'm going to talk about statistical process control and discuss 7 different types of tools that you can use when it comes to statistical process control. So when we think about these 7 tools, there's a few ways we can do this. Well, here's the best way to do this. We're going to put these in different buckets. First, we have our data collection bucket. These are the tools that we are going to use to collect the data. And then we have our data analytics bucket. This is the tool that we're going to use to analyze the data, right? Because you can't analyze any data until you actually have data. So first we have what we call our data collection tools, also called in most cases our real-time tools, meaning these tools collect data in real time. If there was a audio wave of my voice as I spoke, that would be considered a real-time capture of audio, a real-time tool. That's what we mean by real-time. And those 3 tools are going to be your check sheet, your control chart, and your run chart. So when it comes to a check sheet, this is more of a manual process. It's a sheet that is used to check things off, right? You may document the number of injuries in a workplace using a check sheet, or you may use a check sheet to determine what has been used when it comes to certain aspects of production. But this is usually done manually when it comes to a check sheet, again, in real time. And then we have control charts. A control chart is basically just a graphical depiction of how you're producing your product. Think about when you may have been to a hospital and you see that there's a patient that's hooked up to machines to monitor their vitals, their heart rate, things of that nature. A control chart does the same thing for a product in a manufacturing facility. That's how it collects data. It has an upper control limit and it has a lower control limit. And as long as data is plotting within those limits, it's telling you that you're producing a product that is on par with your quality standard. Once you get close to that upper control limit or that lower control limit, it alerts you beforehand to say, hey, you're about to produce a product that is not going to be up to your quality standard. So remember, there's an upper and a lower control limit when it comes to the control chart, and the goal is to prevent you from producing that non-conforming product and to take action and to fix the problem before producing a lower quality product. And then we have what we call a run chart. Now, a run chart and the control chart are often used together. It's like a parent-child relationship, where the control chart is the parent and the run chart is the child. The difference is the run chart gives a little bit more data, specifically what we call central tendency data, right? Central tendency, if you know anything about statistics, we're talking about the mean, the median, and the mode. These aspects of statistics. The mean, which is your average value, the median, which is your midpoint value, and then the mode, and that's the value that appears the most frequent. So when you couple that control chart with that run chart, you get that central tendency data that gives you more of a general idea of how you're producing the quality of your product. So remember, your data collection tools, your check sheet, your run chart, and your control chart are all real-time tools. And now that you have that data, you now have to analyze that data. And that is where your data collection tools come into play. And that's where we look at the histogram, the Pareto chart, and the scatter plot. So the histogram. Now, the histogram simply measures how often something happened, right? If you had 10 on Monday, 12 on Tuesday, 20 on Wednesday, the histogram shows that in bar graph or box chart format, how many happen on each day, how often something happens. So you would take your data and you could create a histogram to show graphically how many injuries you had in the workplace or how many products you produced that were not up to your quality standard, right? And that histogram shows it exactly how it was produced or exactly how many injuries took place. Now, for the sake of this course, when we look at the Pareto chart, we're just taking that information or that data and we're putting it in descending order or from highest to lowest. So we're not just looking at how many injuries took place on certain days or how many products we produced that were non-conforming. We're looking at it from the worst to the least, right? We had the greatest number of injuries down to the least number of injuries, or the greatest number of non-conforming products to the least number of non-conforming products. So histogram, Pareto chart are almost exactly the same. It's just that the Pareto chart puts the information in descending order so that you can look at it from a worst to best perspective. And then lastly, we have the scatter plot. Now, when is it ideal to use a scatter plot? You use the scatter plot when you're trying to determine how one variable impacts another variable and the degree of relationship or correlation between those two variables. Did A happen because of B, or is there no relationship at all? So when it's clear that there are two variables being impacted or one variable being impacted by another, and you want to determine causation of that relationship or correlation of that relationship, you want to use a scatter plot. An example is the taller people are, usually the more that they weigh. That is a positive correlation. There's a positive relationship, meaning the taller you are, the more that you're going to weigh. And then there are some instances that the taller you are may have nothing to do with your blood type. There's no relationship at all. There's no correlation there, right? Those are your data collection tools, your histogram, Pareto, and then your scatter plot. So there's one tool left, and that is your Ishikawa diagram, also known as the fishbone or the cause and effect. Now, this one kind of lives in a lane on its own. It would probably fall under data collection, but it's more specific to processes or root cause analysis. When you want to determine the root cause of something, a fishbone diagram or the Ishikawa diagram is probably the best way to go, because that's when you're actually determining what is the root cause of your quality problem. Again, not specific to any one of these buckets, but if I had to choose, I would move it to the data collection side. So, key takeaways. Statistical Process Control, or SPC, is just a way of determining where your quality problems are and how you can improve the quality of producing your products. You want to put these in two buckets. On your data collection side, you have what we call your real-time tools, where you collect data in real time. Your check sheet and your control chart and run chart, which usually have a parent-child relationship. And then you have your data analytics tools. And this is your histogram, Pareto chart, and your scatter plot. And the last one is the Ishikawa diagram, also called the fishbone, as well as the cause and effect diagram, which is really in a league of its own. But again, if I had to choose, I would put it in the data collection side because it's specific for root cause analysis.